Welcome back. Today we're going to talk about measuring the variability of quantitative data. One of the things about measuring variability of quantitative data is it gives us an additional piece of our puzzle here. And when we're talking about our framework of SOCV, right? So spread, outliers, the center of data, and the variability of data, the ability to look at how much data varies is important. For example, if data doesn't vary too much, if it doesn't vary very much, right? It's all really relatively close together. And that can tell you that maybe there's a consistent result to the test. Maybe it can tell you that the drug trial went really well, like there were a lot of consistent results. However, if data is widely varied, it can tell you a bunch of different things, not the least of which is, is it a reliable test? Were there some people who got zeros and some people that got hundreds? Maybe there are big gaps in the knowledge or in the teaching or whatever it may be. So as we look to measure the variability, we need to talk about the concept of deviation. Deviation is how much a data observation differs from the mean. And the way that we measure this is x minus x bar, right? That's x minus x bar because the observation is x and the mean is denoted, as we've talked about, with x bar. So standard deviation, and this is a huge concept, something we need to be able to articulate and talk about. Standard deviation is the average deviation from the mean of every value. So how do we find that? Well, what we do is we take the sum of all variations. So here's the sum of all variations and we square them. So the sum of every variation squared, and we divide by n minus 1, and then we take the square root. Well, so why does this work? Well, think about it like this. If you've got a data point that's above the mean, right, its variance is going to be positive, right? So, for example, you got an 85 on the test and the average was 80. Well, you're 5 above the average. Well, if there was a value that was 5 below, see 75, it would be a minus 5. Well, we square it because we're not concerned with, in standard deviation, above or below. We're actually concerned with just how much it varied. And so when we do this, what we're finding is the sum of squared deviations and we're dividing by the sample size minus 1. And we do the sample size minus 1 because we're accounting for the fact that it's not the population, it's not every value, it's just a sample. And then we're going to take the square root of that. And I'm going to show you exactly how this works with the data set 1, 2, 3, 4, 5. So if I had some raw data here, what I'm going to calculate is a table. So x minus x bar in this column, and then x minus x bar squared. So when I take the data value, explicit, write down, 1, 2, 3, 4, 5. And I find the mean. So 1 plus 2 plus 3 plus 4 plus 5. So 1 plus 2 is 3, 6, 10, 15. And I'm going to divide by 5. So my mean is 3. So 1 minus 3 would be negative 2. Negative 2 squared would be 4. 2 minus 3 would be negative 1. Negative 1 squared is 1. 3 minus 3 squared is 0. Now, that's an important note, right? If the standard deviation is 0, then the observation matches the mean. And so my standard deviation, my deviation there would be 0. And so we take 4 minus 3, which is 1, square it to get 1. 5 minus 3 is 2. To square it, we get 4. Okay, now we need to take the sum of the squared deviation. So we're going to take the sum here, the sum of x minus x bar squared. Oh, my pen spazzing out here. Okay, so it's going to be equal to 4 plus 4 is 8, so the sum is 10. And we're going to take this, so standard deviation, that's S of x. I should have put that up here, sorry guys. Standard deviation is Sx. So Sx is equal to the square root of 10 over sample size minus 1 would be 4. So I'm actually going to have the square root of 2.5. Okay, so the square root of 2.5 is equal to 1.58. Thereabouts. So that's my standard deviation. So what does that mean? That means the average of all the differences from the values to the mean is 1.58. So if I got the score of, so my mean is 3, that's like my average is 3. So if I got a 4.5, that would be pretty good, right? I'm within that one standard deviation. Okay, so the empirical rule and the normal curve, there's an important note here. Not all data is normal, right? So now, once we start to talk about standard deviation, people are like, oh, well, this rule always applies. It doesn't. It's the empirical rule only for the normal curve, and this is the way that it works. The normal curve is called the bell curve because it has some features that look like this, right? So I've got my curve here, and it's symmetrical. That line is just not good, guys. Gotta move this up. There we go. That's closer. And so my normal rule, my empirical rule says this. I've got my mean right here. And on either side of that mean, as I move out, a certain number of standard deviations. So for example, I've got this average score. If I move above it, 1 standard deviation, and below it, 1 standard deviation. So I'm going to write that in green. So this is plus 1 standard deviation. And this is minus 1 standard deviation, right? Because I can go above or below. Within that 1 standard deviation of a normal curve, there's 68% of data. So 68% of the scores are going to fall within 1 standard deviation of the mean. As I move out from there, another standard deviation. And I move the other way, another standard deviation, right? So now within 2 standard deviations, so when I say within 2, I'm saying 2 on either side, 95% of all data fall within 2 standard deviations of the mean in a normal curve. Important, in a normal curve. And I'm really only concerned about one more. And this is to be within 3 standard deviations. So minus 1 more standard deviation, right? And plus 1 more standard deviation. I am going to have nearly all, or 99.9% 99.7% of data is going to fall within 3 standard deviations of the mean. So what's the empirical rule? 68%. %, and 99.7% within 3 standard deviations of the mean. So 99.7 within 3 standard deviations of the mean. All right, guys, so that's how this works. That's how this empirical rule works, and that's how standard deviation works. So thanks for watching, and we'll see you next time.